All right, we want to write an equation for a tangent line to this given surface at a particular point. Get some random writing over here. So to do that, we're going to use the equation z is equal to f sub x of ab times x minus a plus f sub y of ab times y minus b plus f of AB. So notice that our current formulation for the surface is not written in a function form, but we can rearrange it. We're going to rearrange this to look like z equals negative x squared plus 2y plus 4. And so then our f of AB, or f of xy, is going to be negative x squared plus 2y plus 4. And for our given point, this is our a, and this is our b value. And then this, because it's z, this is going to be f of ab. So we'll find our partial with respect to x. The partial with respect to x is negative 2x. And if we evaluate that at 1, negative 1, we get negative 2. And our partial with respect to y is 2. So that evaluated at the point 1, negative 1 is still 2. And then we know that f of 1, negative 1 is 3 because that's the z-coordinate of the point. And you can do a quick check to make sure that that point does in fact lie on that surface. Otherwise, this all doesn't work. Okay, so from there, now we plug into our equation, or our formula, and we get that z is going to be negative 2 times x minus 1 plus 2 times y plus 1 plus 3. And we can tidy that up a little bit if we want. We get negative 2x plus 2 plus 2y plus 2 plus 3. And so we can finalize this as 2x minus 2y plus z, moving things over to the left, is equal to, what do we have? 1, 2, 3, 4, 5, 7 is equal to 7. All right, same idea. In this example, we want to find an equation of the plane tangent to the surface z equals cosine of xy. And so we don't need to rearrange this one. We're just going to rewrite it as f of x of xy equals cosine of xy. And here, this point is, there's our a, there's our b, and again, this is going to be f of ab, the cosine of 0. And so let's find f sub x of xy, the partial with respect to x. So I wrote a comma in there, but that should be multiplication, x times y. So we're going to take the derivative of cosine, which is negative sine of xy, and then we multiply by the derivative of xy, which is just y, treating y as a constant. So we get negative times y, or we can rewrite that as negative y sine of xy. And if we evaluate that f sub x at 0, 2, we get negative 2 times the sine of 0, but the sine of 0 is 0, so that is 0. And f sub y, same logic here. We're going to get negative x times the sine of xy, and f sub y at 0, 2 is going to also be 0. All right, so our tangent plane looks like z equals, we'll have 0 times x minus 0 plus 0 times y minus 0 plus f of ab, which is just 1. So our plane is the plane z is equal to 1. All right, we're going to now turn to a local linearization. So we want to use the tangent plane to approximate the function value. So our formula L of xy is going to be f sub x of ab times x minus a plus f sub y of AB times y minus b plus f of AB, just like our tangent plane. So first we'll find the f sub x of AB and f sub y of AB. So looking at our formula, f sub x of xy is going to be 2xy, and f sub y of xy is going to be x squared minus 4. And if we evaluate that at our given point, 2, 1, we're going to say f sub x of 2, 1 is 2 times 1, which is 4. And f sub y of 2, 1 is 2 squared minus 4, which is 0. And then f of 2, 1 is going to be 2 squared times 1 minus 4 times 1, which is, again, 0. So our linearization, L of xy, looks like 4 times x minus 2. And we want the linearization to approximate 2.05, 0.98. And that is going to be 4 times 2.05 minus 2, which is 4 times 0.05, which is equal to 0.20.